Welcome back, fellow nerds. We are in it again. All right, so today's video is going to help us understand more about these vectors by trying to answer this question. All right, so we are going to look at this question, right, and see how we can fully grasp the concepts and apply the concepts that we've learned for those that actually have been learning. All right, let's get into it. The helicopter view in figure, all right, shows two people pulling on a stubborn mule. Find the single force that is equivalent to the two forces shown. Equivalent means what? Equal. So the single force that is equal to the two forces, it's like addition of these forces should give you one resultant single force. Basically, this question is trying to tell you, find the resultant vector of adding F1 and F2. No, that's more like it. All right, we'll look at B later. Let's find the resultant. All right, again, so resultant, we have, what's the data? So our data is, we'll have F1, this is F2, right? F1 F2 has 75 degrees, but you should be careful of where this angle is coming from, right? This is 60 degrees. Okay, let's look at, so from the diagram, if we were to draw our own XY plane for like that, okay, so start with F1. F1 looks like our 60 degrees looks like it's coming above the x-axis, right? So that should be the right angle. So above the x-axis is 60 degrees. This is F1, okay? If you're going to add F2 to F1, again, you assume this is its starting point. You draw another coordinate system there. Now, it looks like it's at this side. That 75 degrees looks like it's coming from a negative aspect, right? It looks like that, doesn't it? Okay. But this one is coming from the positive x-axis, so this is okay. So this is okay. This, however, is coming from the negative x-axis, but the angle we'll be looking for should come from the positive x-axis. Again, that is in your second quadrant, so 180 minus 75 give you 105 degrees. So this is going to be our angle, our direction. Okay, let's write that again. Okay, so our data, F1 has got 80 newtons, 60 degrees, right? F2 has 120 newtons. Oh wait, F1 has 120, F2 has, oh boy, 120, F2 has 80 newtons. Oh, I hope I don't confuse this. Okay, let me just, okay, so F2 has 80 with 105 degrees, right? F1 has 120. Oh my god. All right, F1 has 120 and 60 degrees. Okay, 120. F1 120, 60 degrees. F2 80 and 105 degrees. Okay, right, so that is our data. Okay, it's okay to make mistakes. It happens, but more practice should help you, reduce the likelihood of a mistake. Okay, so All right, so let's get into it. Again, these are two different vectors. We have to find our resultant. Oh, what is our resultant from this graphical method? Our resultant will be one that is coming from the tail of the first vector to the head of the last vector. This is your resultant vector. Okay, so f1 plus f2. All right, how do you do this? Again, we've learned vx, vy. You make a table. You make a table. You make a table f1. What? Oh boy. f2. Okay. All right. This should give you your resultant, right? Okay. All right. We know y. Y is sine theta with your magnitude, x cos theta with your magnitude, right? So let's start with f1. Find y, and it doesn't really matter, but as long as you have the true vector quantities, them components. All right, so f1 we said f1 has got what, 120 degrees and 120 newtons and 60 degrees, right? So sine 60 degrees, the magnitude is 120 newton. Okay, f1 vy should be what, sine 60 degrees multiplied by 120 newtons. So that should give you 103.9 newtons. Let's just say 104, right? 104 newtons. Okay, 104 newtons. Okay, f2 will be sine 105 degrees. That's our angle, right? Because 180 minus 75 is 105, like we just did. All right, our magnitude though is 80 newtons. All right, okay, I got that one right. So sine 105 degrees, that's multiplied by 80, that should give you 7.3 newtons. So your vy for f2, you can place that. So here we'll have 104 newtons, you have newtons, right? For f2 you have 77.3 newtons. Okay, what else? X. Okay, let's do the x. For f1, that is going to be cos 60 degrees, 120 newtons. So cos 60 degrees multiplied by 120 newtons, that should give you, f1 should give you what, 60 newtons. f2 cos, what's our angle, 105 degrees multiplied by our magnitude, 80 newtons. f2 should give you what, cos open bracket 105, that multiplied by 80 newtons, that should give you negative 20.7 newtons. So again we place that, this will be 60 newtons, this should give you negative 20.7 newtons. All right, then we can add them. So 60 plus open brackets negative 20.7 close brackets, that should give you 39.3. okay, on that other end on the y you have 104 plus 77.3, that should give you 181.3. Okay, so this is your Vx, this is your Vy. How do you find your resultant? Your resultant, we already know this. Vx squared plus Vy squared. V, that will give you what? X, that is 39.3 squared plus Y, 181.3. Okay, so we have 39.3 squared plus 181.8 squared. Oh, that's 0.3, sorry. 0.3 squared. Okay, you square root that. VR should give you 185.5, sorry, 186 newtons. Three significant figures, like we said, specificity. If you are not given, you can stick to three significant figures. It's much more better that way. All right, let's go to the angle, to the direction, right? To the angle, to the direction. Okay. All right. Again, we have angle is tan inverse Vy Vx. So angle is that. What is our Vy? 181.3. 181.3 over Vx is 39.3. Oh, it's positive, so the modulus doesn't really matter. It still gives us a positive. All right. So is this the angle that we're going to go with? Yes, it is. Why? Because the x is a positive, which denotes that the angle in question is coming from the positive x-axis, which is good, which is exactly what we need. So we have 181.3 divided by 39.3. 3 should look like a 3. Okay. All right. So 181.3 divided by 39.3. That. Then you say shift tan, open brackets, your answer, close brackets. That should give you 7.7. So let's just say 7.8 degrees. Okay, well, the point should be a bit closer, but 7.8 degrees, which is the angle itself, right? So the single force is going to be what? 186 newtons. So single force is going to be 186 newtons, comma 77.8 degrees from the positive x axis. Done. That was A. All right. Let's look at what B was trying to look for. So the single force that is equivalent to the forces shown, that's it. B, the force a third person would have to exert on the mule to make the net force equal to 0. The forces are measured in units of Newton. Okay, we know that. Anyway, we are looking for a force that will make the net force equal to 0. Okay. Now these people are moving in a certain direction, right? So in whatever direction, this is 77.8 degrees. If you are going to provide a force that will give you a net force, is just the difference between the forward force minus the backward force, right? So the forward force is 186 newtons. If you are going to say a certain backward force should give you 0 newtons, right? Well, it means 180 newtons is equal to, this can go this side, change sign like my teacher used to teach me. So x will then be 186 newtons. Hence, the force that single person, or that single third person, should exert for the net force to equal 0 is exactly the same force these the two guys are gonna use, but in the opposite direction. Does that make sense? I hope it is. Well, 186 newtons in the opposite direction is your answer. Or you can just say negative 186 newtons. Same thing, because this was a positive. This is the negative. It's like the opposite of the value on top. But you can just write in words 186 newtons in the opposite direction. You know, just in case you don't feel like you're sure of the direction, you can just stick to words. Easier that way. Okay, so basically that's about this question. I hope we've learned something. Yes, thank you so much. I should hope by now, honestly. I think vector should be free max, right? Well, we'll meet in the next video. Thank you so much. Bye.